Sometimes this book does do that. It puts the problem related to a later concept, but let's see. So what was it again? I'm sorry.
6.4, number 6.
Oh yeah, the absolute last one. Yeah. Oh okay. Okay. Yeah. So. Okay. So they're trying to. Very often, some of the last problems would be like bonusy, but they will also sometimes bleed over into the next section because they want to kind of make you. If you do this problem and then we talk about the next section, you're like, holy shit, I actually solved an equation without realizing you did. How do you find the x-intercepts? What do you do? So guys, we're looking at number 60 from 6.4. If you wanna see what's going on with that.
Find the x-intercept.
How do you find the x-intercept no matter what?
By making the equation equal to 0.
Make y equal to 0. I like it. Now, even before we did the section where we start solving in logarithmic equations, you know how to rewrite a logarithmic statement, right?
Yeah.
What's the base known to be here?
10.
So how do I rewrite this in exponential form?
10 to the 0 equals x squared plus 4x plus 4. Okay.
What's 10 to the 0?
1.
1, and then you solve it. You
Okay.
get it equal to 0, and you factor it, and blah, blah, blah.
Okay.
Make it equal to 1.
No, I mean, it will be equal to 1. Then you have to make it equal to 0 so you can factor and solve. Yeah?
Can you go over 6.3, you said in 9?
No, so it will be equal to 1. But guys, how do you solve an equation that's got a higher power than 1 in it? You get it equal to 0. So then you can factor and set each factor equal to 0. Yeah.
Oh.
Yeah.
Where did I screw that up? Okay.
As far as I know, just right now. 6.3 you said?
Yeah, 39.
Weehaw. To shreds you say? Let's see. 39? Is that what you said? Okay. Alright guys. One thing I really want you guys to get to the point of, there's a couple in here that got kind of weird. This one is, alright, I don't want to say that because I don't want to make anybody feel bad. I'm just going to say, this one, you just pray for this problem. You just, whatever deity you enjoy, flying spaghetti monster, the god of coffee, you just go, please, dear God, give me this problem. Does anyone see why? What is the relationship between
They
e to
kill
a
each
power?
other.
Oh, they kill each other, yeah.
Between e to a power and natural log, you guys are so, I love it. Such glee on killing things. What have I done? I forgot who asked that question. All right, does that make sense? Okay, so they did. Every single one of those acts like this. The only problem is like here, the answer is not 8, right? Because the base is not 100, correct? So can't you make that based on 10?
Yeah.
What's 100? In terms of
10 to
10.
the second.
So 10 squared to the 8th is 10 to the 16. Good, and then it's easy, right?
Okay.
So anytime you can make what's inside
I probably
based
got
on the base,
Which one is that?
39.
it's easy.
30.
39
I
is,
did do that one right. Hey, I did do 36
What?
right. That's crazy.
don't be surprised when you get it right, be surprised when you get it wrong. Oh, real quick, I'm sorry. Who else did not get their quiz back?
Yes.
6.4.
Everybody else got theirs back? Oh,
6.442.
yes.
Wait. Oh, that's 6.3. I was like, okay, sorry.
So Melanie, you said 64? Melanie, you said 64? In 6.3?
Yeah.
Okay. Oh, sorry.
John, where'd you get the?
So this guy here,
Yeah.
Melanie?
I just don't remember what.
This guy here?
decimals there were.
Yeah.
Okay. So they say F is the f-stop setting. By the way, you don't suddenly have to understand photography or anything. It's kind of nifty that we have a content-based problem. So if you are into photography, you know all about f-stop, you know all about this various things. All we have to look at it as is that's where I plug the number that represents f-stop, right? So they tell me that F is the f-stop, and they tell me down here the f-stop is 8, right? Hey. Is everybody with me? That
Yes.
wants to be, okay.
Yes.
F-stop is 8, so where am I gonna put 8?
On the top, 8
On the
square.
top.
So the 8 squared, I like it.
Yeah.
And they tell me the time is 2 seconds.
So you're gonna put
And
that
time
on
in
bottom.
seconds, good, you always wanna make sure that it the setting, the units they give me matches the units that the formula needs.
Uh-huh.
So what am I gonna put there?
2.
2. And then it just becomes a matter of simplifying the inside, and then can you do log base 2 of what you end up with?
So
Does it
it'd
make
be
sense?
it would be 8 squared over 2.
So now you guys can do it, don't say anything.
Yeah.
Is that all right? So that was, if you start to read it, you're like, what the hell, I don't know photography, what the hell? But it's just a plug and chug kind of problem, right? And you'll end up with log base 2 of a number that you can actually break up into a certain number of 2s, so that you can get the answer. Is that okay? So 8 is the F, and 2 is the T. Simplify the inside. No?
Yeah.
Okay.
What about 65?
Okay. Yeah, so now they're telling me what EI is, right? EI, EIO. So look on number 65. What variable that's in this function, in this equation, am I not given the value for in number 65?
EI.
I'm given EI, correct? EI is -2. They also tell me the time is 16, correct?
Mm-hmm.
And they ask me what should the f-stop setting be, so then I just solve for f,
Okay.
right? How do I do that? I
have to
rewrite
rewrite
this
it.
log into an exponential. No?
Yeah.
Is that right? Okay. Sorry, somebody's got their hand up, give me a second, I wanna get a pen. And they're in here. Alright, sure, I'll use red pen, I don't get to use red pen much. Rawr. So real quick, little check-in, anybody not have their quiz back yet? Ah. Everybody else is good? Oh. Maddie.
Oh my gosh, I subtracted
Sure.
the 1
Sorry.
and made 5. And I was like, it's not factoring.
I also have 150 students, so it's
Okay, that makes more sense
a
now.
little bit rough. Okay. Anybody else? Everybody got the quiz? Anybody need a copy of the practice test?
I don't have my quiz from last week.
Oh, I've got it somewhere. Let's see.
Is it factorable out there?
Yeah.
Oh.
You got x equals -2.
It should be, yeah, it should be here. Here it is, okay. Alright. Give me a second. Old man trying to think here, let's see. Everybody, stand back. There's a copy of that last quiz, or did I already send you one?
I think you did, yeah.
Yeah. All right, who had their hand up? Who had a question over there? Oh man, all right. I can't remember who it was I had saw earlier, so I'm just gonna go this way. So what's up?
48 on 6.4.
What section am I in at the moment?
Oh, yeah.
6-3, so close. Okay.
48, the one that you're asking about.
Oh, yeah, okay. Oh, okay. All right, so this one's definitely an example of problem that's pushing you a bit, for damn sure.
Yeah.
So really this boils down to, can you tell what transformations happened? So logarithms, we're not as used to them as exponentials, but does anyone remember what a logarithm looks like in its base form, right? Not its final form? That's an exponential. What's a logarithm look like?
Oh.
So this is an exponential, a logarithm looks like that, right? Because they're inverses of each other.
Oh, yeah, okay.
So its asymptote is the inverse of the asymptote of a exponential,
Yeah.
right? Okay. Can anyone see immediately one thing that definitely happened here?
It flips.
It flips, good. So it's moved up and down maybe or whatever, but it definitely is flipped, correct? You guys, are you with me?
Yeah.
Yeah.
All right, so it's definitely, at the very least, it's going to have what happening to it?
It's flipped across the
Negative
y-axis.
flux.
Across the origin.
No.
So if it flipped across the y-axis, wouldn't it look like this?
It's the X.
Oh, x-axis.
So it's
okay.
been flipped like that, right?
Yeah.
And then it's been moved back a certain amount and so forth. Are you guys with me?
Yeah.
So watch this. This is one of the most, in fact, that is just the most important point on there,
0,
because it's the only intercept it's got,
1, 0.
correct?
So it would be
1, 0.
negative.
Kick ass. So that is, yeah, this is the, I should have made this, that doesn't matter, sorry. So the base function of a log goes through 1, 0,
Yeah.
right? And do you see how it now goes through -3? So if I kind of assume that only two things have happened, and one way that can make this a little bit nicer of a problem is to say there was only two transformations or something.
Yeah.
Otherwise you can go a little insane, which you feel like all of us have gotten a little less sane. But if I just assume that they flipped it, so then it would look like, wouldn't that match the shape of that now if I just flip this? Bam! Now it's like that.
Yep.
And then I just force it,
That way.
how much?
4.
4
4.
So
plus 4.
So what would you, beautiful. Now you can kind of check that. You can check that.
by
Do you-
drawing the parent function and then going like that.
I would just plug that in the calculator and see if it
Oh.
matches that.
Do you want us to list the transformations?
That's what I
Or
do.
just
Well,
give you
it's not a
the-
bad idea to list them for yourself, and then you figure out how to put them into the equation, right? Okay.
Yeah.
I think you guys have noticed that it's a big deal for me for you to list the transformations. So some people just kind of jump. The answer shows up, and there's no list, there's no base function. I'm like, no. Yeah.
Can we go over 51 on 6.4?
Am I in 6.4? Is that the one? I think I'm in 6.4. Yay. Oh, okay, beautiful. Okay, good. This is something I'm very upset at myself that I haven't showed you, so this is perfect. I did not bring all my calculators. I'm very sorry, but
And this
this
what
is-
section?
you guys are going to be so excited about this. All right. I'm going to show you the graphic calculator, then I'll show you in Desmos, but the graphic calculator is what you're going to actually have with you.
Yeah.
I'll translate over here in a second. So that's the right one, correct? Before I start piling into this? Okay. This is so freaking powerful, it's silly that I haven't shown you this yet. And I don't know if you guys have noticed,
I may have-
there's a lot. Have you guys noticed there's a lot?
Yes.
There's a lot in this class. There's a lot. And there's so much I haven't been able to kind of show you that's sort of on the edges. So let me transfer over to here. Okay. So what I'm going to do, in the equation, there's two sides, correct?
Uh-huh.
If I graph one function and I graph another function, what's special about where they intersect?
Is there,
So when I graph a function, that is a visual representation of all the answers to that equation.
mhm.
So when I graph y equals x plus 2, that represents all the answers to y equals x plus 2, correct? If I graph something else, that's all the answers for that thing. So
Mhm.
where they meet
Is
actually
the
works
answer for
in
both.
So where they meet is where the two things equal each other. So I have a let me put this back up here real quick. I have an equation where it's got two functions that are equal to each other.
Mm-hmm.
So to solve it graphically, I'm going to put one side in y1, the other side in y2, and then see where the hell they intersect. That's the answer. You could do that with, listen guys, every frickin' equation you have ever seen and ever will see. You can plot one side and then plot the other side, see where they meet. Do you understand?
Yeah.
Okay. Now all of a sudden do you understand why graphing is so important? At least in this respect. So if I go to y equals, I clear this sucker. And so thankfully they gave me log base 10 because that's on my calculator, log of x minus 1 plus 2, that's one side. So I want to graph that, and then I want to see where it hits natural log of, where to go? X minus 1 plus 2. Oh, what's really silly here is, well, it doesn't matter, Jeff. I don't know if you guys see how the 2's cancel, so I mean, but it doesn't matter. Now let's graph it. We have to adjust it. I don't know what I did with this calculator last, so let's see. Oh, I'm in the normal place. Okay, good. You can already see the answer, right? Now again, if you graph and your window's all freaky, just hit zoom 6. That'll take you back to standard, and then you can kind of adjust it, correct? Do you guys see the answer?
2.
Maybe. That's what I would guess too, but let's verify, right? So one thing I like to do, I love my zoom box.
Yeah.
Zoom box, don't do it, Jeff. Stop it. Zoom box, did I hit it? Oh, it's a little low. Shit, let me do that again. All right, let's see. I'm gonna zoom in. You don't have to do this, but then it becomes really, really, look at that. I mean, now it's really clear, right?
So
Now, real quick.
Is there any way to do it algebraically?
Not easily. This would be a very difficult question to solve because see the two logs in the problem, aren't they different bases?
Yeah.
So if you try to kill one log, the other log still lives. Ugh, right? So real quick, how do I find that? What would you call that? That's where the two lines meet, but what's a more official name? That's where they intersect. So if you go to second calc, intersect. It's going to ask 3 questions. It's going to ask for the first curve. Now watch. If anybody's playing along with me, and I'm sorry I didn't bring my calculators. If I see how I'm sitting on the blue line, and if you don't have colors, you're fine. I'm sitting on one line, correct?
Mm-hmm.
And I know I just call it a line. It's a curvy line, so give me a break. And when I hit enter, watch what the thing does. It bounces to the next one, right? Let me do it again.
Yeah.
I don't want to spend a ton of time on this, but I'm on this, and when I hit enter for the first curve, I'm going to answer that question by saying, okay, this is the first curve, enter, and then it goes to the next curve. So it asks for the second curve. I'm at the second curve, and I hit enter, and now it's going to ask for a guess. So I put the cursor as close as I can, enter. And so there's your 2, 2. Now real quick, why did I not just accept it when you guys said 2, 2? Why didn't I just say, yeah, 2, 2?
Because it could have been.
It could have been 1.9874, comma 2.0739, right? But hey, it's 2, 2. That's awesome. So what is the answer then to the equation? How many variables were in the equation? No. 1.
X.
So this equation asks what x value, where do they meet? It doesn't care what the output is. And in this case, you wouldn't go wrong because they're both frickin' 2, but the answer is x equals 2. Yes?
If it was on like a quiz or a test and it was a decimal, is there a point where you'd like us to cut it off to like 3?
Oh, I would say rounded to 3 places or whatever. I think I said that at one place on the on the practice test, right? Or somewhere else. Yes, like number 7, I said that. So I would tell you, yeah. And if I don't say 2 or 3 places, yeah. If I don't say, obviously you have to bring tape, lots of paper, just tape and then keep going, and then tape and then keep going. And they'll come check on you every few years, see how it's going. Okay. Sorry, real quick, is that all right for that problem? Now I really want you to understand, every single equation we have ever solved, ever, you could do that. Do you understand what I'm saying? No, some of you guys are looking at me blankly. Or I'm just getting used to the fact that you guys give me no reaction at all. It's fine. I don't want to play poker with most of you. I also can't keep my emotions inside, so it'd be easy to make money off of me. Yes?
For 6.5, on question
Did anyone have a follow-up on that? Is it very cool? Yeah. Oh, yeah.
On 54, when I tried to do that, it gave me an error message that said bad guess.
Oh, sorry. I'm not laughing at you, just laughing near you. Sorry. I just love it. It's like the calculator's like,
Well, they don't actually touch though.
okay. So it is possible, they should say that. It is possible there's no solution if they don't meet.
Yeah, that's what I thought. And then it's just funny how it said bad guess.
I love that shit. Bad human. All right, I'm sorry.
Say undefined? Or-
No.
Does not exist.
Again, undefined is specifically when I'm trying to divide by 0. What is it when there's no solution to an equation? No solution. Yeah.
On 54.
Could we go
Sorry.
For 6.5 to 27.
By the way, this side of the room, I'm never ignoring you. I just never see any hands over here. So if you have a question, just shoot that hand up.
Would you solve that by starting off log 5 and the log 20?
Okay. All right. Here's a really good example of the fact that there's so much. Has anyone gotten to the point where you actually looked up what the change of base formula is?
Yeah.
Okay, so real quick, very quickly. Just real quick. Sure. Okay. So if I had to do this, right? I have to do this, but we don't. Now some of you guys know where it is, and maybe more of you know where it is. Let's pretend like we don't know where it is. So I can only use log 10 or natural log, right? Common log or natural log. So I really want this to make sense. This is kind of cool. So I'm going to show you a really quick derivation, and I'll show you a really easy way to remember this. How do I rewrite? So do you all agree this would be really hard to do? In fact, impossible if I only know the logs that are on the face of my calculator, right? You only have log and natural log. Can you rewrite this in exponential form for me?
3 to the 11th. Or
3 to
3
the
y
x.
to the 11th, sorry.
3 to the x.
3 to the y
3 to the y
equals
equals 11. Good. 3 to the power equals the inside, right? So the input becomes the output becomes the input, because they're inverses, right? Okay. Now, how do you solve this equation? Let you take natural log of both sides, maybe? Why would we do that? Because now I can
Put that in front.
put that in front. So notice, isn't this y?
Yes.
Isn't this y? So this equals this.
Oh,
What's on the bottom? What's on the bottom?
the bottom, the base.
The base is on the bottom, correct? Sorry, I'm fine. Physically, I'm fine. I'm just doing something silly. Base is on the bottom, and the other guy's on the top, right? So if I had, for example, if I had log base pi of 4.2, I could write that as natural log of, what goes on the bottom? Base. And the other guy on the top. That's generally true. So if I have log base b of a, I can write that as natural log of a over natural log of b. Yes,
And the natural log can't cancel because it's got a different base?
I need you to understand. Are you saying like cross these out or something?
You can't do that, right?
Why?
Because they have different bases?
No, because I just can't. So if I have square root of 7 divided by square root of 6, can you cancel the square root symbols and make it 7 over 6?
No.
Thank God. No. Hell no. Correct? And I'm sorry, I don't mean to be, I really want to make a big point of that. A log, a natural log, they're just functions. So I can't, so if I have x squared over y squared, I can't just go die to, I can't do that, right? I can't cancel functions that are operating on something. I can't do that. Okay.
But could you simplify them if they were both x terms? It was like x2 over x3, you can like,
No, So if I have, yeah, please, you can't do much of anything with this, right? Oh, if one of them was natural log of 1, that's 0. That's easy, right? So let me show you an example that we know the answer to. What is log base 3 of 9? 2, holy shit, now. So I'm claiming that this is the same thing as ln of 9 over ln of 3, correct? If you have a calculator, can you do for me ln of 3 over ln of 9? I'm sorry, ln of 9 divided by ln of 3. ln of Troy, no, Jeff. Sorry, that was the appropriate level of laugh. 2, right? It's not a proof or anything, but we got the exact same damn answer. I know this is one that we knew it, but if I made log base 3 of frickin' 999, is that easy? Can you do that in your head? Come on. No, I can't either, so it's not trying to flex or anything. So this would be natural log of what over natural log of what?
99 over 3.
Yeah.
And we just leave it like that? We don't
No, now you can
solve
throw it in
it?
the calculator. So
Okay.
this would be an exact answer, and then the approximate would be the decimal you get. Now, real quick, just to make a point, I should have done this earlier when we solved this. Do I have to use ln when I solve an exponential? Why do I use that normally?
Because it's one
Came
less
over
letter.
the thing we did. Yeah, one less letter. But could I have used log
Yeah.
and done all the same shit? So this is also this. It doesn't matter which log you use as long as it's the same one. It's just a funky little side note about how logs work. Logs are funky.
So are like natural logs the ones that the base is not 10?
What's the base for natural log?
E.
Beautiful. E.
E or
Yes.
In what situations do you need to like convert log into exponential?
Oh, if I ask you to, that's a key one, right? So I do that on a few problems, correct? Also, it's the most basic way to solve an equation, right? So if I have log base 2 of x equals -3, how do I solve that?
2 to the negative.
Yeah, 2 to the -3 equals x, right? And then I got the answer. Okay. So that's just, now, I mean, there's a lot other reasons, but for right now, those are the 2 main ones we know. I just ask you to do it, or solving a very basic log equation, right?
Or would we have to take exponential to convert it to logs too?
Totally, yeah. So it needs to be easy to convert this into exponential form. This needs to be easy. A few of you guys made way too much of it, thinking y equals a to, no, screw that shit. This directly relates to an immediate, exact, unique exponential form. There's no guessing, it's all there. What's the exponential form? M to the x equals y. Kick ass, right? Now, going the other way is always harder. I don't know if you're getting all this. All right. So if I have, well, oh yeah, if I have like 4 to the w equals, what do you got, Jeff? B, yes. Here's what you do. To make it into log form, what's the base in this statement? 4. The answer to a log is a power, and the output becomes the input, right? And the minute you write down what you think the answer is, can you check it? Yeah. 4 to the w equals, okay, good, I'm good, right? Do you guys see that? Do you guys see that? You're totally allowed to write something and then go, oh, wait, and then erase it. And then, you can catch a mistake you made. Who cares? Not a big deal. Okay, maybe. Is that all right? Okay. I'll tell you this. Either you guys don't react, or you have this real extreme look in your face and I'm like, you're not saying anything, so. Thank you. Oh, wait, is that the right pile? Yes. Yes.
On 6.5, 39, how do you get the 1 out of the other side of the equation?
39?
Yeah.
Oh. you don't. Which is a very helpful. And that's it. Next. No, I'm sorry. How would you solve? How would you solve this? How would you solve this?
5 to the second.
Is everybody cool with that?
Yes.
If I had a single log equals a number, I can always solve if there's a variable stuck inside. I can always solve it, correct?
Yeah.
So now you're saying to me, that's nice, Jeff. That's nice. That's the easy problem. I'm talking about that damn problem, Jeff. Well, can you consolidate those two logs into one?
Yeah.
Yeah.
X plus 2 over x minus.
Yeah. And then you can just do exactly what I just did, right? Log base 6 of shit, divide, blah, 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 equals 1, correct?
So wouldn't you do
6,
-1, but
6
To the 1.
to the 1 equals this. I mean, that never changes. I don't care how big this stuff gets. Log base 6 of stuff equals 1 is 6 to the 1 equals stuff.
Okay, and then you would just solve in 1 more and figure out which answer.
Yeah, I would multiply both sides by x minus 3, solve for x.
Yeah.
Yep. This is a really good example of a later problem that bleeds over into the next section. But this section was where we learned the properties of logarithms, and then the next section is where we start to use it to solve equations. Yeah.
6.542.
Am I in 6.5? Where am I?
We're in 6.
All right, thank you. Oh, okay. What'd you try to do?
I tried to do what we did on the other problem on 51 and 54 in the other section, but it gave me an error. I plugged both of them into the calculator.
Oh, no. So they're not variable dependent, so that's not gonna work.
Okay.
Now what you could do, I mean, just to get a feel for if this is true, you could do, now you know how to change the base, and actually you're one of the people that knows how to get the log of any base, right?
Yeah.
So you could just calculate log base 8012401 and then calculate log base 37 and see if it's equal.
Okay.
So that, if they are equal, then you're like, okay, now I'll try to do, I gotta do it algebraically now, right? So, real quick, log base 81 of 2,401, does anyone know what that is?
No.
Good. It's not 1.
Sorry.
That's all right. So I don't know what it is, correct? You're good. You with me?
Uh-huh.
And log base 3 of 7, do you get, anybody know what that is?
No.
No. Now, let's assume they're equal. So this would lead to 81 to the x equals 2401, right?
Uh-huh.
And this would lead to 3 to the x equals 7, right? Let's see, how much further do I want to go? So, do you see, I'm trying to figure out how to give you in for the next step without just telling you how to do this. So really, if you can make this equation become this equation, they're the same. Does that make sense?
So we have to change the bases.
Well,
We have to change 81 to have a base of 3.
Yes, good, yes.
Okay.
That's one way you could do it. Is to
Okay.
start seeing the similarities and start seeing how to connect these two.
Okay.
And again, what section is this in the homework? This is, no, I mean,
Extension.
extensions, yes.
Yeah, I know. But
No, just, no, there's not a damn thing wrong with wanting to do, just in case anybody's like, yeah, I didn't understand that at all either.
Okay.
That's like a bonus question, it pushes you a little bit, right?
Yeah.
yeah.
So again, I'm not saying don't do them. I'm just saying if those are the only ones giving you big trouble, that's fine, they're supposed to, right? I have no idea, sorry. Go ahead.
I have a question on 46.3.
Michaela, you have a question follow-up on this, or?
Yeah.
Yeah, go ahead, sorry.
This one guy in the Math Study Center said if they're saying that they equal each other, you would just try and find the powers of both of those big numbers. So that's
Yes,
why I
totally.
found
So another way you could do it
3 to the power of
is,
4 instead of 3 to the power of 4.
sorry, say again?
Because I put 3 to the power of 4, because that equals
Sure.
81, and then 7
Yes,
to
and
the
that's
power
what
of
basically
4.
Sarah was saying, right?
Yeah.
Now here's a really cool thing. See if you guys are cool with this.
This one was so hard.
It's supposed to be. So I'm trying to make it look like this, Russ. Isn't there a fourth power here? How do I kill a fourth power? How do I kill a fourth power?
A fourth root.
Take a fourth root. Now watch. Fourth roots, that notation sucks. Let me show you why. If I just do a fourth root like this, can you see very directly how that just kills the fourth?
Yeah.
Yeah,
And now I take a fourth root of this, right?
yeah, but then
Alright.
the X is still up there.
That we want it up there. We're trying to make it look like that.
Oh.
So how do you do this without actually doing a fourth root? Well, you do 7 is 7 times 7 times 7 times 7. What is that? Do you guys see what I'm saying?
So, yeah.
The only way this would be true is if the answer to this is it's 7. What would the answer to the fourth root of this being 7 mean? It would mean it takes 4 7s to multiply to be 2401. Or you can just put 2401 to the 1/4 power in your calculator, right? 7 times 7 is 49, times 7 is 343, times 7 is something close to this, if not.
It follows.
Okay. It follows. Now I'm think about that movie.
Oh, that.
Yeah. Yeah. Oh yeah.
Could we do 60 on,
Oh, sorry.
oh,
Yeah, I'm sorry. I'll come back to you in a second, Megan. Go ahead, Isabel.
On 6.3.
6.3, number.
48.
What section are we? Darn it. Is it warm here or is it just me? It's probably just me. I guess it's just me. Number which one?
48.
48? Oh! Guys, what is any log of 1?
1. Or 0.
0.
Sorry.
Because what's the power that just about anything needs to become 1? 0. So log of 1 is 0 plus 7 is 7. You're done. Yeah. So I understand. You look at that and you're like, oh my God, what property do you have to use? Oh my God. But this is a simplification problem. Evaluate without using a calculator. So it's a simplification question. Any log of 1 is 0. Because what power does something need to become 1? I'm sorry. Yeah, to become 1 is 0. Megan.
60 on 6.4.
Oh, yeah.
60. All right. Oh, okay. Oh, we just did that one. Where did we do it before you got? No, I think you were here. So that's the one where. How do you find the x-intercept of anything? You set y to 0, right? So you make it 0 equals log blah blah blah, and then you can rewrite the log in exponential form.
Okay,
Yeah. And then you just get a quadratic that you set equal to 0 and you factor it.
okay.
Okay. Yes.
52 on 6.3.
6.3? Weehaw! Let's see. What section am I in now? 6.4. Darn it. Where am I at now? I'm now in 6.2. Jesus. Which number you said?
52. But not this. Okay.
What section? 6.3 number. 6.3 number
52.
52. Okay. Oh, okay. Okay. So like real quick. 51. Answer.
1. 0.
0.
I keep doing that.
All right. This one. What's the answer?
1/3.
Bam. So do you see how it's the same damn thing? It's exactly the same thing, except you got one more step. So what's the answer to that? And then you just subtract 3 from it. Yeah. Right? Okay. Yes. I'm sorry. You're missing all that. Which one? Sorry. 70? Oh, on the practice test? 7. Sorry, boss. 7B? Okay. Whoa. Oh yeah, you're way over there.
60. Oh, 6.4, 60.
Oh yeah, okay. This is a good example of a problem that will not be on this coming test. So obviously I made this practice test before I realized I wasn't gonna get through 6.6, right?
Yeah, okay.
So on the test, you're going to see a problem like this. Is everybody able to handle this problem?
Yeah.
What do you do on this problem?
Solve for X.
Oh.
That's true.
You just
Be a little more
just
specific.
Put it into a log. Into a log form. Right?
You take the natural log of both sides. Yes.
Oh, yeah, okay.
Yes. And then the x comes down, right? So that's an example of a kind of question I'm going to ask you on this coming test.
Yeah.
To
So-
do this problem, you do the same damn thing. It's just more bookkeeping. This problem has more bookkeeping. So real quick, I would just take the natural log of both sides. Why is it that I am taking the natural log of both sides?
I have no idea.
Because you want to get the 2x minus 1 and the x minus 5.
Real quick, guys. Real quick. Go with me. Guys. What would I do to both sides of this?
Cube them.
Cube them, yeah.
Why?
Because
you gotta
it's a
get rid of
cube root.
The cube root.
The x is stuck inside of a cube root. So cubing it frees it, doesn't it?
Yes.
I love it. What would you do first to this? Ooh.
You would.
Multiply both sides by 2x minus 1, which is the inverse of division, correct?
Yes.
Because the 2x minus 1 is stuck underneath, so I'm going to get it up so then I can do shit to it.
Uh-huh.
All right? Where's my variable in this? In the exponent, what's the only function we know that when I apply it, the power can come down? Logs. Okay, that's it. That's
So
why.
then the 2x minus 1 comes down. And
This
2x
whole
minus
thing
5.
comes down. Now watch, guys. I'm not going to do this whole thing. Do you see how the power can come down now, right? You guys with me?
Yes.
Okay. Bookkeeping. This is a problem of bookkeeping. What do I mean? You would distribute this. You would distribute this. You would get all the terms with x in it on one side.
Uh-huh.
You get all the terms without x in it on the other side. And there's a lot of places students lose things and so forth. I'm not going to spend a ton of time on this because it's not on this next test. Yes. Sorry.
So then you would just put the logs into your calculator? and
Not
figure
at
that
this
out,
point.
then
Not at
distribute
this
it?
point. Hell no.
Oh, okay.
Because if you put them, so look, I'm just going to distribute it.
Oh, yeah.
I'm just
okay,
going to distribute
okay,
it,
okay,
right?
now-
And then everything has an x in it. I'm going to move it to one side. Everything that doesn't have an x in it, it's going to go to the other side. And then I'm going to factor an x out and divide by shit I don't want.
Yep.
If you don't understand any of what I just said, you're fine, because this is going to be on the next test, right? This test, we're going to have stuff like that. Less bookkeeping, more direct. Okay.
So for that, would you have to use the calculator to find the final answer? Or
Hell yeah. And for this one too. Right? Because you'll get the natural log of 112.39 divided by natural log of 3. I don't know what the shit that is, so yeah. Okay, maybe. Yes,
Tomorrow, will you be bringing calculators? Because I can't find mine.
I will. I just didn't bring them today for some reason, but I got my little cooler of calculators I could bring. It's a little bag. I just call it my cooler calculators just because. Yes.
how do you know if something's natural log and just like a regular log?
All right, real quick. All right, I think I know what you mean now. Okay, so why did I do a natural log here? Is that the question? I could do, no? Okay, real quick.
Or a.
Yeah.
Oh,
Actually,
for either one, right?
really?
You can take which logarithm, which specific logarithm has the power is able to come down? That is a misleading question.
Both.
What do you mean both? Oh, I see. Between these two. Any is the right answer. Any logarithm they all have the exact same properties, and one of the properties is any power on the inside can come down. You could take any log you want to. If you really like log base 11, you're like, that's my favorite log. I got a poster on my wall, log base 11, right? Just go with it. You could take log base 11 of every freaking thing. Why wouldn't I do that? Because it's not easy. I can see natural log and log on the face of my calculator. Those are the two I would use. Again, why do I always use ln?
Because it's
One less letter. It's literally the truth. That is the truth. I really want you to understand there's not a damn thing special about natural log except there's one less letter to write. And I am impatient and I can't write worth shit. So the less I have to write, both of those are happy, right? Maybe?
So it doesn't matter at all what the problem is, you can use either.
If it's an equation I'm trying to solve and my variable's stuck in the power, I could use any log I feel like using, right? I want to show you something, guys, real quick. This problem here, what was it again? 112.39. How do I solve this problem again?
Take the log of both sides. Or
Yeah, you could take the log or the natural log, it doesn't matter. I'm going to write more than normal.
And then the x comes down.
Sorry?
I thought you wanted the x in the. Oh, that was just the other one because you wanted to. Okay, never mind. Sorry.
Okay. I need the x down because I'm trying to solve for it, right? So don't I get this answer? Natural log of 1. So this would be the exact form of the answer.
Yeah.
Students normally think of decimals as the exact form, but they can almost never be because they normally go forever. So anything you write is not exact in decimal form. This is the exact answer. Throw that shit in the calculator. At the moment, I don't give a shit. How do I rewrite that in logarithmic form? What is that? What if that was my only question? Was rewrite this in logarithmic form? Log base
of
3.
To the.
To the.
Not no guys. Really quick. Okay.
Not to the.
Side lesson. Are you ready? Read this for me. What's that say? Log of 7, correct? All right, what if I do this? Of 7, there's no powers. There's nothing being raised to a power in here at all. The base is the thing that's in a different place.
Yeah.
It's just indicating which logarithm I'm taking of 7. Does that make sense?
Yeah.
Okay.
No, I get it.
You sure? Okay. That was a dejected little head shake. Okay. Now my point here, real quick. So again, tell me how to rewrite this in logarithm. Log base.
Log base 3 of 112.39 equals x.
Well, how would I change the base on this? What would go on the bottom?
1, 3, 12. Oh. Yeah. Okay.
This is not surprising because that's what the change of base formula does, but just another example how you get the same answer. So you could just rewrite this kind of problem in log form and then use change of base if you wanted to. Or you do this and you eventually get to the answer, right? You guys see what I'm saying? Some of you do? As long as you do one of the two, I'm a happy boy. All right. All right. By the way, I want to take right now, since it's quiet, to do the last problems that I said were going to be, I think they were the first 4 in...
Yeah, 1 through 4 review check for review.
So what about we just talk about most of these? Page 671 or something silly, right? Oh, brother. All right.
So is the extra credit for 6.7 due for this test or next time?
Oh, did I actually? All right.
Yes.
Just to show off my cognitive functioning at the age that I'm at, did I say when the bonus sections were due?
Yeah.
I'm pretty sure I said. I think I good. So okay, relatively good for me because I thought for sure I said they were due on the final. At the same time, if you want to try to get the bonus question that's related to the extra credit section, you might want to try a few out. It's just not due tomorrow, right? You guys follow?
What's the bonus question?
What's the bonus section 6.7? What about 6.6? What about 6.6?
Isn't that optional?
It's not bonus. 6.6 is not bonus, but it's on the next
Oh, it's
test.
on the next.
So that homework will be due the day of the next test. I like. Okay. I was about to do something, wasn't I?
You were gonna
Oh, that's
tell
right.
us the first 4 of them.
Oh, by the way, my entire life I've been absent-minded, so I've just been ready. I just been ready for getting older. I was there already mentally. All right. This is the review exercises. So these were the extra 4 I put on that I said I was going to do for the practice test.
Yep.
This first question. Growth or decay? Now watch this real quick. This is a silly thing. What if the base was 1? What if the base was 1? What happens as I change t?
Oh, it stays the same.
Yeah.
So if the base is 1, that is right between growth and decay. It's just homeostasis, which is a cool word. It just stays the same, right?
So neither.
No. That would be neither. I'm sorry. I thought you were talking about the problem. If I have a base higher than 1,
Then it's growth.
and this one specifically, if this is years, this would mean every year it doubles. Times 2 to the first, times 2 squared doubled, times 2 cubed doubled again. You guys with me?
Yes.
So what if the base was fractional?
Then it
So
would
it's
be.
It's gonna be decay.
Right.
Decay, because
Decay.
now I'm cutting it in half every year.
Yeah.
Now, isn't 1/2 0.5?
Yes.
Yeah.
Okay,
So
that's
any base that is between 0 and 1
Is decay.
is decay.
is decay.
Okay.
Cool.
And then if it's, because there was a question that was on a section of our homework that was like, t was in the denominator.
Sure, yeah, this is not exponential.
That'd be
If that was the question, that's not
So that would
exponential.
be,
Now, real quick, I want to make a distinction. What's up, sorry? Yeah, if the question was, is this exponential? No, because it cannot be written in this form.
yeah,
Okay.
okay.
Because that is exactly not that, right?
Yeah.
Okay.
Yeah.
What if I had this? Is that decay or growth?
That would be decay.
What did we look at here? What exactly did we look at here in each case?
Base.
Yeah, try it again. Is that that's growth? Because what's the base?
E.
Which is bigger than?
One.
Oh, yeah, okay.
One.
This just tells me the neat thing about the base of E, I can interpret this number as the growth rate per whatever, right? You guys kind of follow. That's another reason why E is special. Yes.
Oh, I was gonna ask, like, didn't you once say that E was like used for average growth rate or population or something?
Yeah, E is a great base because then the numbers that are related to, that are there with it mean very definitive things, and yeah, it's just the best base to use for most growth. The other thing you see very often is this, because then you talk about doubling time and so forth, right? Yeah, so there are reasons to use other bases for sure. That's why you see those. There's that one problem with the forest and the trees. Could you see the forest for the trees? No, the one about which forest is growing faster or whatever, right? And so one guy's base was 1.026 and the other one's 1.059, whatever the hell. So you can tell they're both positive, they're both growth, but one was higher growth, right? Maybe. Okay. Okay. So what was that one? That was number 1. Number 2. So I'm going to give you a problem like this where it's just a plug and chug problem. You guys see that? So the population of a herd of deer is represented by the function this, where t is given in years. To the nearest whole number will the herd population be after 6 years, right? So to the nearest whole number, which makes sense. I don't want 0.73 of a deer running around.
That'd be scary.
That would be a little weird. Like, what movie am I in? So you just
would
do what?
Plug in for T.
Yeah, so
Yeah.
can somebody do it for me? Plug a 6 in there for me. Can you do it? Yeah. We'll compare answers.
426.8.
426, okay. Yeah.
Is this in 6.3, those of you, or 6?
No, this is the chapter review.
Yeah, it's like the whole chapter review at the
This is
very
the
end.
chapter review.
Oh.
At the very end of the chapter.
Okay.
Yeah, so that's the correct answer. Do you guys get 426.8,
Yeah.
blah, blah? So what would you say? You would say 427. 427 deer, yeah.
426.8?
Yep, so you'd say 427.
So, for one, how would you know if it's neither? If it's a fraction?
Oh, if it's not even exponential. So
Oh.
somebody else asked me the other day, do you guys remember what 1 over x looks like if I graph it? I might have to use 2 hands, but I don't know if you guys remember. looks like this,
Yeah.
right?
Oh, yeah.
So if I just look at this side, isn't that like decay?
Yes.
Yeah.
Yeah.
Is it exponential decay?
No.
No, because it's x to the negative 1. So there are other functions that represent different kinds of decay. You can have oscillating decay, which is neat. You can have all different kinds of decay. This one is specifically exponential. So I don't think, no, there's only one problem. But if I had like 156 t to the, oh, how did I do that?
That was weird timing.
That was really
That's
cool.
interesting.
Someday I'll have the thing I can actually push like a calculator here. I can just push the buttons. Boom. Yeah, if I had like t to the negative 3, it's neither. It's none of it, because if it is decay, it's not exponential.
Because it's a fraction.
Because it's not in the form constant to a variable power. If I have t to the negative 3,
Same every time.
that's not exponential, correct? Students look and they go, well, Jeff, it's got an exponent. No, what does exponential function mean specifically?
Powers.
What about it specifically? What's in the
Means you're
power?
multiplying by a fixed.
Variable is in the power. That's a exponential function is when the variable is in the power.
Oh, not a number.
So if I have x squared, it's got a power, correct?
Yeah.
But it's not exponential.
Okay.
2 to the x, exponential, variable's up there, right? Now be careful, I said it a little too broadly. It's gotta be able to be put in the form a to the x, right? Or b times a, whatever. So 3 to the 1 over x, not exponential.
Yeah.
It's just exceptionally weird. And yes, it is. I don't know if anyone's tried to, anyway, you guys could try to graph 3 to the 1 over x and see what it does. It does neat things.
Also, if the coefficient is 1, it's not exponential because 1 times itself.
Oh, if the base is
number
1.
of times.
Yeah, if the base is 1. That's sort of like the point I had up here. If the base is 1, it's silly.
Yeah.
Then the function just becomes 156, because it's just always going to be 156, right? But it's a nice thing to realize that's 1 is this, greater than 1 is that, less than 1 is that. Does that make sense? Actually, it's like this, sorry. So greater than 1, equal to 1, less than 1. Decay. Okay. Baby.
So the number of the exponent doesn't do anything to that equation. Like, doesn't make it grow or decay. It's
Oh,
only the base.
the only thing would be, for example, is this growth or decay?
Okay.
Yes. And just to put this in, do you guys see how this is 3 to the negative 1 to the t? Is that cool?
Yeah.
Isn't, because what would you do with the powers?
Multiply.
And then you get this, correct? Not a big thing, you guys with me? So, and what's 3 to the negative 1? Okay, now you can really see, is the base less than 1? Between 0 and yes, so that would be decay. So that's why any whole number or any number bigger than 1 to a negative variable power will be decay. Because you could flip it and make it a fraction. Which is another reason why the 0.825 thing was decay, because 0.825 you can make it into a fraction less than 1, right? Okay, so we got that one. This one is the exciting one, right? Let's see. We write this down and then we'll do it. What does it say? 2.25? 60.75. Yeah, this one doesn't say you can do that, so you have to do this one by hand. Yeah. Don't get too excited. All right, so I know and again, they do a horrible job of this, but we have to assume that this is a very basic, let me write it more like what I think they put, I can't remember what they do. A times, there it is, Jeff, there it is. Okay. We have to assume it's a very basic exponential because they don't say otherwise. So you guys remember, well, let's see. The most direct way to do this is to just start plugging information in. So when I plug a 2 in, I should get a 2.25 out. Is that cool? So when I plug a 2 in, I should get a 2.25 out. When I plug a 5 in, I should get a 60.75 out. Now this is where I stopped because I was trying to do that one yesterday in a rush so you guys could get the quiz started. But I want you to realize, so right now if you look at that, you're like, how the shit am I going to figure out what A or B are? Right? Does anyone feel that way?
Don't, you have to smush the two, equations together.
How?
You do, 60, or, you
Like
do,
that?
No.
Oh, sorry.
No, you do, 2.25 over 60.7.
Okay, good.
Equals A.
So I would do it this way. If I divide the two equations, which is a neat thing that I don't know if you guys realize you could
I
do.
did it the other way. Does it matter?
Not really, but this just
Okay.
makes it nice. See how the A's cancel?
Yep.
By the way, why am I allowed to do this? Real quick, aren't I supposed to divide both sides by the same thing? I'm dividing this side by 2.25, right? I'm dividing this side by AB squared, correct?
Mm-hmm.
But isn't AB squared equal to 2.25?
Yeah.
So if I divide by 2.25 and I divide by AB squared, I'm divided by the same thing. So you can actually divide two equations by each other, which is weird. These cancel, everybody with me?
Yep.
Yeah.
Somebody help me out, what's that?
127.
Something went wrong.
27.
Oh, sorry. It's 27.
Oh, 27.
Yeah, sorry. I did it the other way. So
And what's b to the fifth divided by b squared?
B to the third.
And what b
And then
cubed is
take the
27,
third.
b is, what do I cube to get 27?
3. And then plug that in.
So now, I could plug that into like this guy. Now I have more information. So I get 2.25 equals a times 9. Is that cool?
Uh-huh.
Because I know what b is now. So now it's like, sometimes what I do is call it dominoes. Once you know one, it always falls back, and now I can figure out the other one.
Yeah.
And now to solve for a, I just, of course my a looks like a baby 9, but oh well. I divide by, that's crazy sauce. And then I'll figure out what a is, yeah.
And it's 0.25.
0.25, okay. What's up? You good? You good? Okay. So then what's my answer though?
F of x equals 0.25 times 3 to the x.
Kick ass. So you're putting your a in there, and you're putting your b in there. Cool. There's this, you can do it a different way if they give you more information like they do in the tables, which is what I was trying to show you, but again, I was kind of rushing through it just so we can get to the quiz. But yeah, you can always do it this way. Okay. It would have been much nicer if they would have just given us a y-intercept, but they didn't, the bastards. And that's why this is a little bit more gross. Yes?
What's the difference if you get a y-intercept?
Oh, it just makes it nicer because then one input would be 0 and then b goes away and then I can figure out what a is immediately, right? In fact, if I know the y-intercept, that is a. Because b to the 0 is 1, right? Okay. Y-intercept, knowing that makes most everything easier. That's why it doesn't tell us that all the time. Okay. All right. Oh, do we have one more up there?
Yeah, number 4.
Oh, that's the one. Okay, so let me attempt. You could do it exactly the way we just did it. You all with me? You could set up a times b to the x. You could plug a few in. Are you with me?
Yep.
Okay, so does everybody see the problem, right?
Which ones would you plug in? The first and the last one?
It doesn't matter. It doesn't matter. It doesn't matter. I would pick the first two because they'll make the exponent the smallest, right? So I'm going to do this two ways. If I look at the clock, I'll know. Yeah, maybe. So I sort of wrote this down semi-nicely. All right, not really. So real quick, I could do it exactly the way we just did. So I'm going to assume the answer looks like this. I'm not really assuming that part of this problem is it exponential? So I already saw that it was, and I'm sorry. How do you tell it's exponential?
By dividing.
Yeah, linear would mean there's a constant difference between two, right? So here I would take like this one divided by this.
Gotta make sure it's multiplying by the same thing every time.
Yes. So what's 0.9 divided by 3? What's 9 divided by 3? So what's 0.9 divided by 3? 0.3. Okay. What's 0.27 divided by 0.9?
0.3.
0.3, right? And you can see how this is again. Do you guys see how 0.3 seems to be the continuing factor? So the difference between linear and exponential: linear is based on repeated addition, exponential is based on repeated multiplication, right? Makes sense because exponents are multiplication. So the funny thing is, when they give you more information, I know what B is already. So that's one little thing you can do. Don't I already know what B is? You guys see? Well, what is B? We know what it is.
Oh, yeah, okay.
What is it?
0.3.
Yes, because that's what I keep multiplying by, right? We just figured out what we keep multiplying by. We keep multiplying by 0.3. So now I just have to use 1 point to figure out what A is. Because I already know what B is. So of course I'm going to pick the one that's the most straightforward, right? Do you guys follow what's happening? Is it pretty cool with the fact that we know what B is?
Yeah.
Real quick, if I had this, is that linear or exponential?
That's linear,
Linear.
Why?
because you're adding.
It's adding
Adding 2. So every time I step 1 on the x, I go 2 on the y. So
Yeah.
what do I already know in this equation then?
That B equals two. Oh, and equals
Try m is 2, correct? We just basically did the same thing. M is the repeated addition I'm doing. B is the repeated multiplication. So if I see the difference here, that's related to M. If I see the quotient here, that's related to B. And now I can just plug in like I would plug in the easiest point. So when I plug a 1 in, the answer is supposed to be 3. Do you guys see that? When I plug a 1 in, I left my x and y off, but oh well. So then you just solve for A, divide by 0.3, and you get A is 10. So then I get y equals 10 times 0.3 to the x. And real quick, can I just, what the hell, Jeff? Isn't 10 times 0.3 is 3. Can I do that? Right?
No.
Make it look better, Jeff. What's wrong with you?
No, because you gotta do exponents first and then parentheses.
There you go. So we had this discussion yesterday. I love it. There's only one 10 here, but there's x 0.3s. I can't make x 3s when I don't have enough 10s. That's one way to look at it. The other way is I have to do this power first before I can multiply, and I can't do that power, so I can't do shit. Yes?
Why was the 3 in front of the equation?
Here?
Yeah.
That's not in front of the equation. What does this point say? When I make the input 1, the output is 3. So I'm just using the points they gave me. Does it matter which point I pick? No. But of course I picked the nicest one because I'm trying to be nice to myself, right? It's my job to be evil to you. Yes?
Is that decay? Because it's running one?
Totally. That is obviously decay, right? I love it. And why? And again, look at the equation we got. How can you tell it's decay?
Because.
The base is between 0 and 1.
Mhm.
Cool.
How did you know to plug in the first y? Because if you were
No. Again, what did I just say? To figure out A, which point do I have to use? It doesn't matter. I can use any damn point. Which point am I going to use? The nicest one. Does it make sense?
if you were to use a different point,
Well, let's see. Let's see if Jeff knows the shit he's talking about. You never know. At any point, I could just go insane. That'll make everybody in here feel so safe. I'm sorry. All right. I'm on my meds. We're all good. So I've got this so far. Are you cool with this? Okay. You tell me another point. What point do you want to pick?
0.9.
All right. So when I plug a 2 in, if I plug a 2 in, I'm supposed to get 0.9 out, right? Man, I wish I could write. So do you guys. I'm sorry. So 0.9 equals, now let's see if you guys can do this. What is 0.3 squared?
0.6?
0.09.
Yes, 0.09. You don't just square the 3, you square the place it's in, right? Isn't this 3/10? So the answer would be 9/100ths. Bam, right? And then when I divide by 0.09, I get 10 again.
Oh. Okay.
And I don't know if you remember when we did problems like this and we had to pick a point to put in, and it didn't matter which point we picked. Of course, it didn't matter because it's all the same line. This is all the same exponential function. It doesn't matter which point you pick because they're all going to lead back to the same function. Does that make sense? Okay. That was my biggest reaction. I had like 3 people shake their head. Yes, I'm so happy. Okay. Yes. So that was the extra 4 that I put on the practice
Uh-huh.
test? Okay.
Can you just go over which ones probably won't be on the test? Just so that we're not stressing out about
That is
we
awesome.
can't figure it out.
That is so awesome. What do you mean? Which be more
on
Which
specific.
ones that'll be on the next
on the
one?
practice test?
Yes.
Can we just go through which ones won't be on the test so we don't have to worry about doing them or practicing them
So 2
for
things.
the test?
I completely understand the desire to know that.
But you're not gonna
Second
tell
thing, I ain't telling you shit.
Yeah, I was gonna say.
Of course, why do I do that? Because there's no way in hell I could put a problem that represents everything you've done in chapter 6. Do you, right?
Yeah.
How long would
Yeah.
that test be? Do you want that test?
No.
And Sarah's saying, no, I don't want that test. I just want you to tell me what shit you're throwing off. So it becomes a test we could do. So the point is, you have to know everything. And then I'm going to pick some stuff, right? So I'm sorry, yeah. Y'all know this. Y'all know this. And I don't blame you for asking, right? You always ask.
Did you go over 6?
Uh,
Or did you
oh,
start it? Or?
what did I just do? I just had a practice test. Shite. Are you right here? Yes, Jeff. It's right there. Number 6.
Yeah.
Oh, so number 6 is this in reverse.
Okay.
Okay, so what I always do.
Like Spanish, sorry.
Well, maybe I won't do this the way I do it, but expand just means to undo.
So just make it look like that?
Yeah, so it means the main thing I can do, let me see if you guys agree with me. The main thing is this division.
Yes.
So I can do the log of the top minus
The log of the bottom.
log of the bottom. And then this, one thing you should do is you should immediately rewrite any root, make it a power, right?
Yeah.
This is a product, correct?
Yeah.
So then you can break that apart using.
Using the
Addition?
Yes.
Yeah.
So let me give you guys the answer key. Because we're almost out of time anyway.
Okay, that gets me started. Good.
Somehow I shoved all the answers on one sheet, which is always exciting.
You have to count these
So the range is what matters. I'm just looking at the first 2 problems. It's the range that changes based on where it is. The range basically stays the same.
Yeah. You need the domain. Multiplying for
I'm sorry.
Oh no, so I did do it right. I did do it right before. No, I didn't. Wait.
So just to point out a couple things,
Can we go through 1?
real quick. 7B we talked about. I said in class because I just wanted to say this won't be on the next test.
Yeah.
So we'll do this one for the next test. Which one are you looking at? Sorry.
Number 1.
1.
It's because the first one looks like I did it right on the homework, but then the second one.
This here.
Yeah, B.
All right. So the nice thing with exponentials, the domain is easy. It's all real numbers, right?
Uh-huh.
It's the range that could change, because the range normally is 0. Oh, I see one little thing.
But the domain,
Everybody is allowed to laugh at me. Make it like that.
but the domain on A.
You guys
was
with
the
me?
one that
Make that,
changed.
Yeah.
because what is 2? Isn't 2 the asymptote? I wrote asymptote there, and then I used a freaking bracket. Bad, Jeff. Yes.
So, but in 1A, the domain's the one that changes, not the range.
So,
And then
how are logs and exponentials related to each other?
they're
They're,
inverses.
So the domain of one is the range of the other. The range of one is the domain of the other.
Oh, okay.
So if the domain of an exponential is all real numbers, the range of a log is all real. And again, what's a log look like?
Okay.
What's a log look like? I want somebody to go, then you can make a cabin out. So a log looks like this, right?
So the domain,
So it goes all the way down, and it goes all the way up. So the range is all real numbers,
Okay.
right? Negative infinity to infinity.
Yep.
Look what I did for the domain. I did the exact same thing we've done before. What must be true about the input?
You have to you have to do
greater than
the
0.
It's gotta be greater than 0.
Yeah.
So the inside has to be greater than 0, and then I solve it. Done.
yeah.
Any function I ask for the domain, you just say in words what has to happen. And then you write what you just said in Mathish, yes.
So the domain of an exponential is
All real numbers, yeah. Because I can raise a number to any power I want. I can raise it to a negative number, I can raise it to 0, I can raise it to a positive number, right? Okay.
Could you do like really quick, like a quick sketch of like what an exponential like base graph looks like versus a log?
Well, yeah, so they're inverses of each other, right? So what's the asymptote of a exponential? Where's the asymptote? No.
It's at 0.
Oh, it's a 0.
Yeah.
Oh,
And it
for
goes
the
through
base.
1, and it goes whee. Like that, right?
Uh-huh.
Yeah.
So log base A is going to be the exact same thing except reflected around the y equals x line, right? So this is the asymptote for a to the x, correct?
Mhm.
So if I flip that, it becomes that.
Okay.
So there's an asymptote here, and it goes through 1 just like that went through 1, and it just has a
Okay.
reflective, yeah.
Okay.
Logarithms are some of the slowest growing functions, which makes sense because exponentials are some of the fastest growing. Since logs are inverses, they're growing forever, but they grow really slowly. Yeah.
Stupid question, but if they're inverses, would the domain and range switch?
That's what I just said.
Oh.
The great thing about inverse functions, everything about x's and everything about y's switch. And domain is x's, range is y, so they switch. Maybe.
So would that be like if the range, if the domain was like negative infinity to infinity, would the range of the inverse be negative infinity to infinity? That's what I'm.
Yes.
Okay.
And if the range of the original function was 2 to 7,
Oh, the domain would be.
so the domain of the inverse function would be 2 to 7. Yep. All right.
If I see
What's up? Sorry.
my paper, wait, it's in here, sorry.
Good.
Is there a stapler?
Oh, it's over there, but I can
Oh.
give you. Where'd it go? Oh, they got it. I can put another one.
I'm gonna need to get that. I'm gonna get that. Okay.
Sure.
So I couldn't come yesterday because I thought that my